Okay, right. So this right here is your virtual wind tunnel. Okay, so this is how you'd set it up. And this is made up Formula FSAE car, right? And if I enable the walls, okay, if I enable the walls, you can see that, Sashanka, the flow here, how would the flow take place? It's going to take place like this, correct? So now what I can do is I can go to transform, translate, or sorry, rotate. I can just take my car. I can say rotate it about the z-axis by 10 degrees. When I do that, that's going to take some time. And this is what you call as a 10-degree yaw angle. So now what's going to happen is there is definitely going to be a difference. Your flow is asymmetric, right? Your flow is asymmetric. So this is going to cause a difference in the downforce between one side of the car and the other side of the car, right? So you need to understand that. You need to make sure that you're still getting the required value of downforce so that you can make the turn in a proper manner. And what I'm saying is, so depending upon the track, right? So you can imagine that there's a track like this, and that is why the car is actually turning like this, correct? So depending upon the track, you should have a good understanding of what are the typical yaw angles. And this is where experience comes in. You take the car, you drive it in the track, do a test drive, and then understand, okay, what are the turns, what are the turn angles? And you understand that, okay, for 95% of the time, or 90 or 70% of the time, the turning takes place, maybe that's a 10-degree turn. Then you need to make sure that you test it accordingly. Mayank, do we change boundary conditions when we change in yaw angle? That's a great question. The answer is yes. Why? Because when you're turning, you are most likely going a bit slow, right? Which means your inflow conditions can no longer be 80 km/h. It has to be smaller. How small? Again, that depends upon the average turn. And that is where you need a baseline data. Where would you get the baseline data? Well, you have the car and ask your driver to drive it around. And if you're able to measure speeds at the corners, that's great. You know that, okay, my average turning speed, and maybe some guys can help you. If you guys have the data, someone can help me out here. If you have test driven your car, what is the average speed at which you make the turn? Can anyone share some details? Maybe this could be test drive that you did in your local track that you have in your college. 20 to 30, 30 to 35. Okay, that seems like a lot. But anyway, if you're making the turn at that speed, then that should be your boundary condition. Okay, there we go. So that's the type of analysis that I want. 90-degree turn, maybe around at 30 km/h. So then your inflow should be adjusted accordingly. But that's it. That's the only boundary condition that you have to change.